Write each equation in slope-intercept form. So we're going to distribute on this one. That would give us negative 2x plus 8. And then over here we would have 3y plus 3. In slope-intercept form, we want y equals and everything else to go to the other side. So we're going to subtract 3, which gives us negative 2x plus 5 equals 3y. And then we will divide by 3. So that'll give us y equals, this would be negative 2/3 x plus 5/3. If you prefer to have it with the y first, so it's in that format y equals mx plus b, we can just swap this to the other side. Go ahead and solve the remaining for y to rewrite them in slope-intercept form as well. This is a digital lesson, so if you have access to it, go ahead and open it up in Great Minds. It says, it's been a cold week. The high temperatures tripled from one day to the next. Give an example of what the temperatures could be. So if it's a cold week in Fahrenheit, a cold week might be 20 degrees as the high. If it tripled, 20 times 3 would be 60. That's still somewhat cold. One day's high temperature and another day's high temperature add up to 14 degrees Fahrenheit. Give an example of what the temperatures could be. It could be 5 degrees on one day, and then 5 plus 9 would give us 14. Do you think it's possible to find one temperature that is 3 times as much as the other when the temperatures also add up to 14 degrees? Explain. So for example, we used 5 and 9. Those added up to 14. But if we did 4 times 3 would be 12, but 4 plus 12 isn't 14. 3 tripled would be 9, but 3 plus 9 doesn't equal 14. So I think it's possible, but I don't think that they would be whole number degrees. I think it would have to be in the middle. We can work with one constraint at a time. Earlier you said 60 is 3 times as much as 20. How do the points coordinates relate to the temperature you chose? The first temperature is graphed on the x-axis, and the second value is graphed on the y-axis. So it uses the points 20, 60. Here are some of the points graphed by classmates. What do you notice? I notice that they form a diagonal line. You might also notice something about the slope of that line. The coordinates of these points represent examples where the second temperature is 3 times as much as the first. Let x represent the first and let y represent the second temperature. Write an equation between the relationships of x and y. So y was found by multiplying the x value by 3. And you can see it goes through my point 2060. Let's think about the second constraint. Earlier you said 5 and 9 have a sum of 14. How do the point's coordinates relate to the temperature you chose? The first temperature is also graphed on the x-axis. And the second temperature is graphed on the y-axis. So it uses the coordinates 5, 9. Here are everyone's points. You can see that 14 plus 0 makes 14, 13 plus 1 makes 14, 10 plus 4 makes 14. What do you think the point's coordinates represent? The coordinates represent the solutions to which x and y values have a sum of 14. If you look at the first temperature and the second temperature, those points add up to 14. And for this section, it shows to write an equation. So I have the x value plus the y value must equal 14. So now we have this equation graphed, and the equation from before, where it said y equals 3x, is also graphed. Let's look at both the lines that represent the two constraints together. What do you notice about the two lines? I notice they have different slopes. So they intersect. They also have different y-intercepts. You can see that one crosses the y-axis at 0 and the other crosses the y-axis at 14. It looks like they cross somewhere around 3.5, maybe 3.2, and maybe 10 or 11, 10.5 or 11. The goal was to find two temperatures that meet the following constraints. One is 3 times as much as the other, and they have a sum of 14 degrees. Based on the graph, do you think there are two temperatures that satisfy both constraints? Explain. Yes, the point 3.5, 10.5 is on both lines, so it is a solution to both equations. If we did 3.5 times 3, that would be 10.5. And if we did 3.5 plus 10.5, that would also equal or have a sum of 14. Is it possible for the two numbers to sum to -1 and have a difference of 9? Let x represent one number and let y represent the other. Write an equation for each constraint. So x and y have a sum, meaning adding up to -1, and a difference, which is a subtraction phrase, of 9. Sum of -1, difference of 9. Here are the lines. Oh, no, graph your lines, so we need to move these points. Okay, so we have x plus y is -1. So one possible point would be 0, -1, because a 0 in the x and a -1 in the y would add up to -1. You could also put in a -3 plus 2. So -3 +2 would make -1. A difference of 9. If I put in a 9 and a 0, that would make 9. If I put in a, let's see, a 10 and a 1, that would also subtract to make 9. Using the graph, what ordered pair appears to be the solution? So where they cross, that ordered pair is 4, -5. And it says, do the values have a sum of -1 and a difference of 9? Well, 4 plus -5 does equal -1. And let's see, 4 minus -5. Remember, if you have a minus and negative, you add the opposite. So 4 plus 5 is 9. So yes, they do. Graph the system of equations and estimate the coordinates of the point of intersection. These are both written in slope-intercept form. This first one has an intercept of 4 on the y-axis and a slope of -2, which means from that point we're going to go down 2 and over 1. Because remember, -2 is a fraction of -2 over 1. We still need to do the second one. So for the second one, we need to start at +7 on the y-axis based on our y-intercept. And this tells us to go down 1 and over 2. So from here, down 1 and over 2. This one. And it says, graph the system and estimate the coordinates of the point of intersection. So where do those cross? It crosses at -2, +8. Can you determine whether the ordered pair satisfies both equations? Well, the 8 is the y value, and the -2 is the x value. -2 times -2 is +4. So that is 4 plus 4 is 8, so it satisfies the first one. The second equation, 8 is the y value again. -1/2 times -2 for the x value, plus 7. -1/2 times -2 is +1, and 1 plus 7 is 8. So it also satisfies equation 2. Is negative 5, 3 a solution to the system of equations? If we replace x with negative 5 and y with 3, that does equal negative 2. In the second equation, if I replace x with negative 5 and y with 3, does it equal negative 15? Well, we have 3 times negative 5 is negative 15. Negative 15 minus 3 is negative 18. So that is not equal to negative 15, which means no, it is not a solution to the system. And then we have to write how we know. Negative 5, 3 does not satisfy the second equation because negative 18 is not equal to negative 15. It says, which line is the point negative 5, 3 on? It was only a solution to that top equation, so only the line represented by this. When we plugged it in, when we plugged in the coordinates, negative 5 plus 3 does equal negative 2, but 3 times negative 5 minus 3 does not equal negative 15. You said that the point negative 5, 3 is only on the line represented by x plus y equals negative 2. Graph the system of equations. Does the graph confirm your answer on whether negative 5, 3 is a solution to the system, and explain? Well, we need two values that add to negative 2. So that could be like negative 1 and negative 1. Or 0 and negative 2. For this one, we need values that make negative 15. You might also change it into slope-intercept form. To do that, we would subtract the 3x from both sides. That would give us negative y equals negative 3x minus 15. And then if we divide by negative 1, that turns it into y equals 3x plus 15. So we can't quite fit 15 on our graph here. So we might try a different point on the line. If we plugged in, let's say, negative 1, for example, three times negative 1 plus 15, that would give us negative 3 plus 15, which is 12. So that still isn't quite on the graph. Let's try negative 2. Negative 2 times 3 is negative 6. Negative 6 plus 15 is positive 9. So the x value here would be negative 2, and the y value would be positive 9. Negative 2, positive 9. And then the slope is 3, which would be up 3 and over 1. And that really isn't super helpful either because I'm going to run off the page. Let's try another point. 3 times negative 4. Well, 3 times negative 4 is negative 12. If I add 15 to that, that gives me positive 3. So the coordinates would be negative 4, positive 3. And you can see that it only crosses the first line and not the second line at that point, negative 5, 3. These lines do intersect, but they do not intersect at negative 5, 3. So it is not a solution to the system, but it is a solution to the first equation. That is the end of lesson 2. Feel free to check back for other lessons coming soon.